Hello, everyone. My name is Sławomir Jacek, and you won't be able to pronounce it because it's Polish name. I am from Poland. I've been a security consultant and tester for like more like 15 years. And recently I'm focused mostly on providing trainings and doing some research in Bluetooth Low Energy, NFC, RFID, smart locks, embedded, and so on. And I really love to share my knowledge at various like events. So about today's live lab, yeah, I hope you got the link to the slides. So I tried to make the slides as like detailed as possible for you to follow up all the practical exercises we'll be doing. But let me know if anything goes wrong, if something doesn't work in the chat. The best send just public message. I will try to follow up the chat. If not, Steph will help me with that. And I've been told that this is recorded and the video will be available in a few weeks, or I don't know exactly, but it will be. And after the session finishes, I will also be available on the Discord channel, and we made two separate channels actually. One is with voice and video, so I can respond to the questions on this video channel and the voice channel as well. And I must warn you that I'm not like fully operational today. I woke up with a fever and I had to take some medicine, but well, it's kind of working, but not fully. So if I stop making sense or something doesn't work, just let me know in the chat. So okay, so the agenda for today is like we'll start with this very introduction on what is BLE, and we'll set up this hands-on hackme application that we will be interacting with. Then we will follow up with Bluetooth Low Energy advertisements. This is the data that is transmitted, broadcasted by various devices to other like nearby ones. So we'll see how it exactly works, how is the data created and how it's structured. We'll see some sample packets like beacons, some other advertisements. We'll have a look at a system of operating systems that send such packets by default, like Windows and iOS. And iOS, by the way, it's possible to get the people's phone number from this packet in some cases. And we'll also have a short brief about also very hot topic in this area, like this contact tracing applications. That they also use this technology, this BLE advertisements to share information about persons that you have met. And this should take about less than an hour, I hope. We'll see how it goes. In the second hour, we'll continue with Bluetooth connections. So we will connect to the simulated device that works like just like a real one. And I will introduce you with the basics of GATT, Bluetooth services and characteristics. I hope it won't be like too difficult to understand because we will do it hands-on on real devices, so you will feel it better and understand it better, I hope. Then we'll follow up with hacking very simple devices with using just a phone. And we'll finish with hacking smart locks, also using just a phone and all these skills that you have learned before. And I will finish with some like links to what can be done next, where to look for more information and so on. Let's start with this introduction and this lab setup. Yeah, you are most likely, sorry, like this. You are most likely familiar with Bluetooth. You used it every day, like in your headphones, like speakers and so on. But this was Bluetooth Classic, also called Basic Rate Enhanced Data Rate, so BR-EDR. And this is a different technology than the new Bluetooth. This old Bluetooth, let's say, is focused on speed. So to get you like better audio quality and so on. A new Bluetooth 4.0 is a different use case. So it mainly is focused on preserving energy, just like the name says. So it's low energy, and so it tries to send small packets and not really a lot of data. So it's usually a small packet about the current state of some sensor, or a small packet to switch on or off the light or something like that. And you may have heard about Bluetooth 5, which slightly changes this because it introduces higher speeds with new like physical modulation. It gives a better range and some other extensions, but it's not really yet there. I mean, there are lots of devices that claim they are Bluetooth 5, but they use just the single subset of these old features, or maybe not. And from our perspective, this new Bluetooth 5 will be mostly the same as Bluetooth 4. So you don't need to worry a lot about it now. There are billions of devices, and not only like gadgets or something like toothbrushes and bottles and plant watering sensors and something like that, but also home appliances, also credit card readers, and also smart locks and banking tokens. So there are really lots of devices using this technology, and every new startup, IoT startup, probably will use it as well. It's very like popular technology. And if you ask vendors about the security of it, how do you think what you will hear? Like, well, of course, it's military-grade security, and of course, like, it's super secure. It uses AES, the same as military, our own PKI encryption and something like that. Like, highly secure. We've been doing this for years and so on. And I'm not sure if it's really accurate. If you compare this to like headlines. Like smart locks can be hacked in seconds, like Bluetooth smart locks can be hacked, of course. Top-selling handgun safe can be remotely opened in seconds. Huge security flaws and so on. Well, this may be exaggerated because, you know, news are just looking for clickbaits, but so it's difficult to tell exactly where is the truth, like, and from the end user perspective, if you look at the Wikipedia definition of smart lock, it says that end user cannot actually tell whether it's secure or not because of the complexity of this technology. So we are left with, I don't know, security professionals, and I haven't met a lot of security professionals that are fluent in this. So like, they usually like I am a pen tester and I know a lot of pen testers, and they are really good like in web applications, mobile applications, but this wireless stuff is still not really common knowledge. And it looks like that maybe we need some like hardware for this. There are very complex tools to set up, like they never work. And also maybe we need to buy some vulnerable devices to practice and something like that. So it's not really a lot of resources to like get in with this. So here comes my idea to make this BLE hackme that is hands-on, because I believe that this is the best like learning perspective. This is hands-on and practical, and it works on a standard laptop. So I struggled to make it work on Windows laptop because it would be much easier to make it work for me on Linux. But I wanted this to be like for as many people as possible available. And we use the phone that will be our hacking tool, and you can apply this later to real devices and to like later as a security base for your later knowledge. And last but not least, have fun. So the idea is to install this BLE hackme on your Windows laptop. It will simulate various real devices that on the Bluetooth layer will act like real ones, and then we'll use the Android phone to connect to it. And I hope you got the link to install this application. It's already in the Microsoft Store. It's not yet public because I don't know why this certifications go like longer than expected. So you need to have this direct link. You will not find it in the search at this moment. Hopefully they will certify it in like hours or days at last. So you can download this from this Microsoft Store. And you can also have a look at the source code, because this is free and open. So I published the source code in case you don't want to run an exe file from untrusted source, let's say untrusted, with hack in the name or whatever. You can just, if you prefer to download like Visual Studio, that is about 3 gigs. So it's free. Community edition, you just need to download it, then install, download this project, open this SLN, and just then simply press this display button here, and it will start debugging. So I will ask you to like turn on the developer mode, and it will look more or less like this. So you just open this project, download it from GitHub. So it's like starts to to browse it, to open it. You can already browse the source code here. So you will see, like, for example, for each task, you will see the XML with layout and also the C# code. It should be pretty easy, like, and then you can just press the display button to debug and the application should start. So it was my first C# code, so I also were able to do it. So it's not really like difficult. And during this debug, you will see some output, some nice output here. And this output, by the way, will be helpful with debugging the crashes. So after opening this application, the expected output is to see like this, hooray, your device is supported. But I'm afraid that some of you might have seen this. So this means that there is either no Bluetooth turned on, like on my laptop I had problems with, because my Bluetooth was just sleeping after no usage. So I had to like turn it on and off again, or maybe restart the laptop or whatever. But this may also mean that you are you have unsupported Bluetooth adapter that isn't Bluetooth 4 compatible, or at least isn't isn't accepted as Microsoft as Bluetooth 4 compatible. And unfortunately, this is the case in virtual machine. And it's also the case with like the single most commonly used Bluetooth CSR adapters. So most like external Bluetooth 4 dongles that you buy, even with like other vendor names, they have just this CSR chip inside, which isn't supported by Microsoft. I don't have a lot to help you at this moment. You can have a look at the frequently asked questions linked here. But hopefully you will be able to join and play this later on a different equipment. And there is one possibility to run it in virtual machine, at least one confirmed, that if your laptop's internal Bluetooth adapter is connected via USB, not PCI, that is the case for Lenovo ThinkPad X1 Carbon 7. I have X1 Carbon 6 and it's PCI. So if that is the case, you can directly connect your Bluetooth internal adapter via USB pass-through to virtual machine, and this will work. And if you have some other like workarounds how to make this work, please let me know. And there is a rare case where your system can be N without media pack, like some enterprise systems come without media pack. And I use these media features in some exercises later, so the application may crash if you don't install it. This is my first ever C# code. So, and expect crashes, bugs, and exceptions because they will be, I know they will be, I couldn't like debug all of them. I will try to do my best to fix them later. But unfortunately, you will experience crashes, and sorry for this. This is just a newborn, so please be like careful with it. So I know that this will be very frustrating when your application crashes and it doesn't save the state. So you won't be able to see your progress. You will have to like do everything again if you want to see it, to have this 100% progress. But I will do it in some next release, maybe like send up some issue to the GitHub so we'll maybe able to work this out together. I hope you were able to install it. This hackme application and start it. If not, hopefully Steph maybe will be able to assist you somehow. Try this frequently asked questions options and so on. And if not, just don't worry because you will be able to recreate all the steps later with a different equipment and recording of this session. And the second tool we will be using is called NRF Connect for mobile, and we will be using it on Android. I know that some of you have iPhones, and this is also available on iPhones, but unfortunately iOS severely limits the low-level Bluetooth functionality for applications. So this application doesn't have as nice features as this Android version that we will be using. You will be able to do some stuff using iPhone, but most of these tasks you won't be able to finish. So Android, unfortunately. You may be surprised during installing this application that it asks you for your location. And I want to be clear, I'm not affiliated with the vendor. I just use this app because it's very it has a very nice features. It asks for this permission, for this location permission, because it requires you to, it is required by Android to be able to scan nearby Bluetooth devices, because based on the Bluetooth signal, you can somehow tell the exact location. So that's why in order for the application to work, to be able to scan Bluetooth, nearby Bluetooth, it needs to have the access permission to the device location. This was the setup. I hope you were able to actually make it work. At least a few people I can see in the chat that told that it works. Someone is talking something about Ubuntu. We'll get back to Ubuntu later, and we'll follow with Bluetooth advertisements. So in Bluetooth 4.0, we have two basic types of communication, let's say. So one is that we have a central device like a beacon. This is a very small device with a big battery that transmits some signal. And it transmits this signal to every receivers in range. And this is basically one-way communication. So this is just a broadcasted signal to everyone that is in range. And the second way of communication is using a connection between two devices. So like your mobile phone connects to a smart lock in order to send a command to unlock, for example. And we'll cover both of these types of communication, and we'll just start with this first like one-way broadcast. Yeah, I know this presenter is vulnerable, but you are not able to hack me remotely. Of course, I know Marcus. Okay, so this is just how this application looks like. And it is on the left side, you should see the list of tasks. They are supposed to be followed in sequence. So they introduce the skills that will be needed for the next ones, but you can just jump around if you like. In the middle, you have first the short theory introduction and the description of the task. And this should be self-explanatory, but if it's not, just file an issue on GitHub or whatever if you think it's missing something. And then you have a submit. You have to submit the solution. In some cases, those will be you will have to write something here and submit. And in some other cases, you will see like a simulated device that, for example, in this case, you will have to turn on this light bulb. All right, so if you start this NRF Connect, it will start scanning for nearby devices. And depending on your environment, you may see a lot of devices. And sometimes it may be difficult for you to figure out where exactly is the one you want to connect to. You may try to pinpoint it by the name or something, but it's sometimes if you have too much devices, it is useful to select this filter down and then choose filtering, for example, based on the signal strength. And if you move the slider to the left, you will see only the closest devices. So the lower value, the closest devices. And in this way, you will be able to see your device, which is the first task. So let me just switch to my hackme. So it started, and it should look like this. And the first step is to find this device. So I will just start my mobile application, my NRF Connect. Okay, so when I start looking for devices, I have lots of nearby devices. Well, maybe not lots of, but it's difficult to tell which exactly is this hackme. So I can use this filter to, let's say, like 50. And I have just my two laptops, and one of them is this hackme device. It's currently broadcasting the name of the laptop. So in order for this to submit, I will need to tell the name of the laptop. Mine is laptop P0 VKCD CKD, sorry. CKD Q. Submit. Sorry, laptop P0 VK CKDQ. Okay. Okay, so congratulations. And I was able to get like the first task done. And by the way, you can scroll down here and you have a summary with all the tasks, and which is like already done. All right, so we can get back to the next task, and this will be the Bluetooth advertisements. Let me get back to the slides. All right. So, have you been able to fulfill this first task? Did you find your device? Let me know in the chat. No. Yes, it works. Someone wasn't able. So maybe you should you could try to move to beacons. And then back to this first step. So this device, this will reset this broadcast. Or if it still doesn't work, maybe try to restart the application or whatever. Yeah, so I can see most of you have been able to do it. So this is required for follow-up. so I'm really glad that it worked. Right. So you can submit this device name, and it should accept it. All right. So we've already found out that devices can broadcast their name. Are you able to tell me a device that would be a problem to broadcast its name? Do you think that there could be some device that you own and you don't want others to know that you own it? I will turn on such device, and maybe you will be able to tell me what kind of device it is based on the signal. So I will try to scan again, and yeah, so you can see this device here. And how do you think what kind of device this is? Okay, so yeah, well, yes, it is a sex toy. So it just broadcasts its name, so you can see the name of the device. And well, maybe it's nothing, but for some people this could be a problem. And there is also a list of the device names and the models if you want to have the exact model. And also other people were mapping this on the streets, whatever. But let's get back to advertisements. So the advertisements are just the packets that are broadcasted. So you will see it works like just like I mentioned previously, that you have like some broadcaster, and it transmits this everywhere to everyone nearby, to every receiver nearby. And these packets are basically public, but with a little small exception that is really not common. So we can assume that these packets are basically public for everyone in range. There is no pairing required and so on. So this is just a public broadcast. And I think I'm not needed here. So if you have a look at the list of the scanned devices, you will already see, among others, for example, the icon. So NRF Connect shows you an icon for a device type. You may see a device name that is optional. Not every device can have it. You will also see how frequent these packets are sent. So this is the delay between each packets. So it's 100 milliseconds. So it means that this is sent 10 times per second. And you will also see the power, and the lower, the closer. You will see optional connect option for the devices that are connectable. And this scanning may stop after a while, so you may need to like refresh it again. And if you tap on the device name, so not yet on this connect button, but just on this device name, you should see some slightly expanded information about this. There's some more information about this this packet, actually even more interesting things happen when you click this row button. So this row button is a very nice feature that allows you to see the row hex of this transmission. So this is how this row bytes sent low level by the device look like. If you have a look at this, and if you're like familiar with hex, you probably will notice pretty soon that this is not really complex. Like if you start analyze this byte by byte, it starts with, oh, sorry, it starts with this first byte, which is the length of this field. Then it's followed by the type of the field. In this case, it's 01, and then the value itself, 1A. And then follows the next field, which happens to be like the length of 5 bytes, type 03, and value 0xa18, 0f18, and so on. And then you have another value, which is length 16 bytes, which is in hex 10, followed by the type and followed by the value. So it is very basic encoding of length, type, and value. No like real mystery here. This type is defined by Bluetooth generic access profile. So this is a specification that defines what types are like possible and what should they be used for. And most commonly used are, for example, 0x01, it means flags, and 09 is complete local name, and so on. So if we compare this to this information we got previously from this NRF Connect, we can see that it shows us this type 01 as flags. It shows us this 03 as list of services. We'll get to the services later. And it also shows us this 09 as device name. By the way, I encourage you to take this device name, hex encoded, and decode this ASCII hex. So it will turn out just this device name that you saw. So also no mystery here. And if you want to understand the flags, you can click on this more button, and you will see the flags decoded. Maybe I'll just quickly show you how this works on my phone. Okay, so all right. This is my hackme device advertisement. When I click on this row button, I see this raw data. This is actually not my beacon, not my device, just this Windows advertisement that I will explain in a moment. Because it switches to Windows advertisement after a while, so you will need to like catch it. So this is the packet we are interested in. In row, it looks like this. So this is just how this raw packet looks like. And if you want to understand how these flags are decoded, you can click on the more and flag services, and you will see exactly why this 01A means, what it means exactly. And by the way, you may have noticed that your laptop is switching for a moment to this Windows logo. Your Windows laptop advertises its own packets that must work at the same time. So it like glitches for a moment. So we are here interested not in the packet that is with this Windows logo, but with this generic Bluetooth logo. All right. So let's get back to the slides. So this task was to like figure out what exactly is in the row advertisement. So you will just need to like fill this in here. So I hope you will be able to do it. Let's move on with the next task, which is beacons. And beacons are like okay, oh, sorry. Right. Yeah, just like I mentioned, it might get tricky, but it might get even trickier here, because if we switch to this task beacons, it turns out that now this Windows advertisement has priority. So you mostly have this Windows packet, and it just glitches into iBeacon for a moment. I will try to show this live on my phone. So if I refresh this, my Windows laptop should, yeah. So you saw this. I hope there was a beacon just for a moment. And I don't really know how to enforce this to be longer. Sometimes you can just try to switch back to these advertisements and back to the beacons. So maybe it will have a slightly higher priority. Otherwise, you will need to just catch this beacon, yeah, like stop scanning at the right moment. Yeah. So I was able to stop scanning at the right moment. So I have this beacon information transmitted by my hackme. So this beacon, right? So this beacon transmits UUID and two numbers, major and minor. UUID is usually per vendor. Major means usually some kind of group of objects, and minor means specific object and also signal strength. So based on these numbers, you can tell the exact device. And if you have a look at the raw advertisement of this beacon, so I will just show it again here in my phone. So I will click the row. Once you catch this beacon, I will click the row, and you should see only one type. This type is FF. So this type means manufacturer specific. So it can be anything inside, but it is actually a beacon value. And if we compare it again, you will see that there is also no mystery. So in this type FF, you will have just company type, beacon length of data, this row UID in hex, and then these two numbers also translated into hex. And that's all. This is what is transmitted by the beacon. So it's not really difficult. Sorry again. Yeah. Okay, so the beacons can be used in practice for various things, like indoor location, display context information, because you can tell exactly where the exact location inside. It can be a key finder. I have a few of them. It can integrate with your home automation. It can check you in a restaurant and get free food. Accessing such application. But I would like to introduce you to yet another usage of this. So this is how it works. So it's in German, so I didn't put up the volume. So the idea is that your partner is not taking attention to you. So you wear a special pants, and inside this pants, you have this special chip that informs your partner that you are available. And there's also the other sex option. I don't want to be accused of being sexist or whatever, but you get the idea. So there is this pants. Oh, by the way, my phone already found out that this has moved. It has a chip inside, and this chip looks like this. The small one, and if you move, it starts transmitting and informs the application. So this is how this chip looks like, and it actually transmits iBeacon. So maybe I will just scan again here. Yes, so you should see this iBeacon information, and also it's playtime. So it just transmits iBeacon, and the other application is looking for this specific iBeacon signal, and if it's available, then it's just goes into play mode, whatever. Right. So you may have noticed a function called clone here. Yeah. So if you press this clone button, it will allow you to clone the signal. So this would be the demo. So it works like when I shake this, it just informs, shows a pop-up. And it also transmits this iBeacon. So I can clone this iBeacon signal, then go to the advertiser tab, and like start advertising. And it works. And it's just that easy. So this iBeacon signal is not public. It's public, so everyone can clone it. There are beacons who like encrypt, let's say, these communications, so they change the values, but they can also usually be hacked. Okay, there was a question in the meantime if you can do anything on the Linux. Yeah, you could use GATT tool, HCI tool, LE scan to see advertisements. You could use other tools that use this low-level GATT stuff, like BetterCap, among others. We will cover for now only this Android, because this will be like easier to follow. All right. So in order to clone it, this is like the instruction if you would like to clone some advertisement data. And I hope you do have a general idea how advertisements work. So now let's move on to what your systems advertise. So your Windows and your iOS is advertising such packets, and we already saw this packet before, so it was glitching for us. This is just defined in the Microsoft BLE beacon specification, so it's just a device type and some hash. I don't know how this hash is generated. This is not really public. The thing interesting for us is, could we use this for tracking users, for example? So in Bluetooth, the device MAC address can be changed. The good practice is to randomize it and change it to like every 15 minutes or so. So operating systems do that. Standard devices don't. Windows changes this like every 15 minutes. But this second one, this hash changes like every 1 hour. So you could like longer track a user. Even if the MAC address changes, you could like look at this payload and track the user longer. But slightly more interesting is with iPhones. NRF Connect shows an Apple icon by this iPhone. And if you enhance to the packet details, you will see in the FF field, so again, this manufacturer-specific field, you will see some value. And interestingly, this value changes a little bit after you, for example, turn the screen on and off. Do you see any difference like here between these two packets? So again, sorry for that. Yeah. So there is a small difference, and it turns out that the Apple devices advertise device type, and they also advertise device device state. For example, you can have like screen on, screen off, and something like that. There is a tool called Apple BLE, I don't know how to pronounce it, that just scans for these advertisements and shows what kind of device it is. It's maybe able to fingerprint the device and show what is the state. Is this a Mac? Is this a phone? And what exactly is the state of it? But more interesting stuff happens when you use certain features of your iPhone, like AirDrop, where you want to share a photo with someone nearby, or if you want to share your Wi-Fi with your friend. Then this packet is much longer. And inside this packet is not just the device state, but also, among others, a few bytes of hash of the phone number and a hash of email. Do you think there could be a problem? It's a hash, it's a one-way function, right? So you can't really break it easily. But if you think about it, they didn't really thought this function well. Phone numbers have a very strict format. So especially if you know in which area you are exactly. So you can have a country area number, and in this case, you could create a list of all possible numbers and create pre-computed hashes of all these numbers. So create some kind of rainbow tables. And then if you see this packet, then just take these few bytes and look up this in your table. There might be some collisions, because these are just few first bytes of the hash. But it's easy to discard invalid phones, just trying to iMessage him or whatever. There's slightly more info about it, and there are more people who reverse this Apple continuity protocol. If you are interested in this, have a look here. I hope you will be able to solve this iBeacon and also another manufacturer-specific advertisement task. The challenge might be that this is really difficult to catch because these packets have lower priority than Windows ones, but you can try switching to a different task and back, and maybe it will advertise again. Another interesting advertisement that got a lot of attention recently was the contact tracing or exposure notifications. And I will focus only on the ones that are made by Google and Apple. The other ones work similarly. And if you have a look at this specification, they just define how exactly this advertisement looks like. So they use the same packets, the same type of packets that we saw in iBeacons and other advertisements with device name and whatever. They just structure it a little bit. They use slightly different fields. So in the specification, they say there will be flags, 16-byte service UID, and the data. So that's exactly where this interesting data is. So this packet looks like this in NRF Connect. And so you will just see service UID and some data. And the raw version looks like this. They don't actually send the flags. I don't know why, because this is obligatory by specification and their own specification, but in practice they don't sign it. But they do send this 16-bit UID and also this value that is actually interesting for us. So it consists of this rolling proximity identifier that is changing, and also 4 bytes of metadata that are encrypted. So this metadata is just some version and so on, and it's encrypted. So you could clone it the same as we cloned these iBeacons. So you could use Android to clone it, and it will work just like these iBeacons we have cloned. Yeah, and so what? You could change this value and whatever. So what? Well, just for an exercise. So the cloned one will look exactly the same, just a different MAC address, but they don't check this MAC address. But if you would like to play with it, I also wrote a small script to broadcast because by the Bluetooth specification, every Bluetooth chip can not only receive the data, but can also transmit. So just by the specification, every chip can also be broadcaster. So we can turn into a broadcaster phone that we already done it in Android. You can turn into broadcaster your laptop, your small device, or all such like small Bluetooth dongle. If you'd like to play with it and advertise something from Linux, this is really simple. So this is just the command you just need to like put into the console in Linux, and it will work. So right. Yeah, well, you actually need to read like very fine Bluetooth specification to understand this. But I would brief you that this is not that difficult. You just need the command OGF and command OCF. It means that set advertising data length and advertising data. And then you follow just with this advertising data. So it's just a row hex bytes like we saw here in this packet. There is 0, 2, 0, 1, and so on. So it's not really like a mystery. So if you'd like to advertise something using this small BLE USB adapter or your built-in adapter in your Linux, you could use my script that I made here just to simulate this COVID packets and change them like every second. So you will see like they are changing every second. And so on. And they are stored later in this, if you have root access to your phone, you can just take them from a level DB database that is not encrypted on the phone. And it just stores these simulated IDs that I created along with this fake like encrypted metadata. And like whatever. If you'd like to develop such application, because I played with it a little bit, it was restricted only for this like certified applications, so you can add your own application in this database. But that's just a side topic. Let's get back to on track to the BLE connections. Regarding this COVID-19, I know that lots of people are very interested in like hacking it and so on. So I just wanted to show you how this works on BLE layer. So there is no mystery. It's very simple packet, like public, whatever. You can replay it and so on. It changes in 15 minutes anyway. But if you'd like to play a little bit with it, you can just try. So I hope that by now you are familiar with these Bluetooth advertisements. They can be iBeacons, this can be just a simple device name, or this can be used for contact tracing. And you are encouraged, of course, to like look for all the devices advertisements and try to decode them. Now let's follow up with Bluetooth connections. So basically, we have covered this one-way public broadcast so far, and now we're moving on to this two-way communication, where there is, in the typical scenario, there is an application, and this application is called Central. or GATT client. This is confusing, I know. Central is the client. And there is also a peripheral. Peripheral is the device, and it's the GATT server. So you connect from your phone to a device peripheral. This can be like, you can also be a server and client at the same time, but let's not overcomplicate things for now. So we'll just focus on these connections. And so far we have passively observed our hackme device. And now let's move on to the task number 6. And in this task, you will actually connect to the device. This is a single most important thing to understand that looks really complicated at the start, but actually is pretty simple if you try it hands-on. So it's called GATT, Generic Attribute Profile, which is another Bluetooth specification that defines services, characteristics, and descriptors. So the theory is that like every of the service characteristic or whatever, they have UUID, and some UUIDs are very short, 16 bits, and some are longer, proprietary. The shorter ones are registered for like simpler use. They are actually long, but they are shown as short. And a service is just an abstract object that groups several sub-objects called characteristics. And characteristics is just a single bucket that holds a value. And this value can be read or written to based on the properties. So, for example, there may be a battery level service that has battery level characteristic inside it, and you can read the value of this battery level. That's the theory, and I know this is confusing. So let's actually connect to the device. Okay, so if I switch to task number 6, and I will scan again. Now I will connect to my device, and the NRF Connect should show me this list of services. So what I see here is a list of services. So this is generic access service, generic attribute service, device information service, battery service, and so on. Some of these services are mandatory. So every device should have, for example, generic access. And if you click on the service name, it will expand into characteristics inside of it. So you have a device name characteristic, and you can also have like other characteristics inside this service. This task is pretty simple. You just need to write down all the UUIDs, these short like 2 bytes, like this 2A00, that are inside the generic access. So I hope you will be able to do it. So let's follow up with reading the characteristics value. For that task, you just need to read the battery level value. It is randomized every time you run this. And this battery level value will be inside the battery service. So if you click on battery service, you should see battery level characteristic. And this characteristic has a property to read. So you are able to read the value. And this is indicated by this down arrow. So you can just touch this down arrow and you will see the value. So in my case, this is 3%. So let's see if that works. So it's just 3% submit. Congratulations. So I hope you will be able to finish this. And let's get back a little bit to the slides, because I suppose you might be wondering, again, you might be wondering, how did this happen? Okay, so we just used the red. So how did this happen? But there wasn't pairing. Like, normally, you are probably accustomed to the fact that before you can get something from the device, like read some data, you will need to pair with it first. And there was not pairing at all. So on the contrary to the previous Bluetooth version, the pairing, or otherwise called bonding for a longer relationship, let's say, in Bluetooth Low Energy is possible, but it's optional. It's not mandatory. So guess what? Like, most devices do not implement it. So there is no Bluetooth pairing used in Bluetooth Low Energy devices, at least most of them. Most of the smart locks, appliances, and so on. You may be able to pair with your smart lock or your Fitbit or whatever, but in many cases they do not implement the pairing, or implement security only in a few selected characteristics, not in all of them. So anyone could connect to such device and read some values or send some values to the device. Of course, the data can be secured on the application layer, so the data can be encrypted on the application layer, so not anyone can send. Anyone can send, but the device will discard it. But in many cases, it's just very simple. But if you will encounter a secured characteristic, there are two options. Either your NRF Connect will stall and will disconnect, and it means that the device requires some pairing mode, so you need to press a button or whatever. But there are also devices that will allow you just to pair without any special pairing mode. So there's actually no security. Anyone can pair with it and then read this, let's say, secured value. Okay, regarding this 0x prefix, the question, it should work both with 0x and without. So you can follow with this, of course, later. Okay, so there is I recently saw this guy on the street, and he was I don't know, 20, 30 meters from me. So with my very good eyes, I catched this specific smart band on his arm. So this is, I already can recognize these smart buds from 30 meters. So I know what exactly to look for in my NRF Connect. So I filtered by the device name, and I was able to connect to this device and read some device information, serial number, whatever. And I could, the guy of course didn't know about it. So I could use this to tracking specific users, even if the device changes its MAC address, but a lot of them do not change. But even if it would change this MAC address to randomize, to secure the user's privacy, I could connect to such a device and just read the serial number and whatever, in order to pinpoint to specific one. Yeah, you will expect crashes, unfortunately. So we will debug this later, but I hope I will be able to fix all the crashes later. Anyway, another way of receiving value from the device is called notification. So notification is useful when you want to receive a value without actually manually reading it. So you just subscribe for a value change, and it will automatically update whenever the value is ready. So the device will send you the update automatically. So the next task is notifications. Okay. And our device is also has a heart rate service. So inside this heart rate service, you have a heart rate measurement characteristic, and you can read the value, and it's now 87. I read again, it's 92. But I can also subscribe to it, so I just will press these 3 down arrows, and it will update automatically. So it changes every second. So your task will be just to write it down, like ±5. So I hope you will be able to do it. So this is how notifications work. And another important attribute, GATT attribute, is descriptor. So the descriptors are optional, and they may have the most commonly used ones are characteristic user descriptor. This can be some text value added for human readable text to describe what exactly is this characteristic used for. So if you press this down button by the characteristic user description, it will read the current name, the text value. That is just this next task. And by the way, there is also a very commonly used second type of characteristic descriptor. It's called client characteristic configuration, and it changes once you enable or disable notifications. It's actually if you want to see it in row hex, it's 00 or 01 if you subscribed. So this would be it for the basic concepts for reading data from the device. And let's maybe follow up with some slides. All right. Okay, so here's about the descriptors, and we are finally going to write something. So this is another task using characteristic write. You can find the descriptor. About the crashing, we'll figure it out, I hope. Sorry for that. This is just the first release and my first C# code. And I also see that you can find the descriptor, but I'm sure that if you follow up with these slides, you will see this descriptor in the heart rate service. This is just below this heart rate measurement characteristic. You should see the descriptors. So maybe I will just point it here. Sorry. Yeah. Okay, so the descriptor is just here, and here is the button to read its value. Okay, so let's get back to the write. Our device has also another characteristic. You will easily find it because it's proprietary characteristic. Just give me a sec. Yeah, okay. So let's get back to this, right? And again, back to our device. So in the services list, you will see the standard standard services with this short UID. These are defined by Bluetooth specifications. They are used for generic access, battery, heart rate, something that is commonly used among the devices. But if the manufacturer wants to have control over his own proprietary device, he just generates random UUID and uses it. So it doesn't have to be registered. It can be any random UUID as long as the mobile application knows what to look for. So here's this unknown service. It's unknown because it's proprietary only for this application and SmartBub. And you have some characteristics inside of it. And they also have descriptors. So you can read the descriptor and it says light bulb on and off. So it's like really easy to figure out which characteristics is used to turn the light bulb on and off. So you can read the current value of this light bulb, and the current value is 0, 0. And who's going to tell me how to turn on this light bulb? So I'm counting on you. Oh, someone already did that. Okay, so what should I send to this light bulb? Light bulb on. Yeah, great. Yeah, you already done this. 0, 1. Yes, exactly. Thanks. So you just use this up arrow by the characteristic name, and you can send the byte value of 0, 1, and the light bulb magically turns on. So isn't it fun? Like, yeah, you can turn it off again using 0, 0, and it turns off again. So you already got this task solved automatically by turning the light bulb on. And the next task is to send a kind of different writes in different format. So there might be devices that accept only the write without response, because standard write is that you low level, you send the packet and the device confirms that it received the packet. But the other type of write, low level, is just sending packet without confirmation. And these two are different properties, actually. So you will see, for example, on one characteristic write, on another you see write no response. But sometimes you just need to send like the special type of. So I will not show you exactly how I did this, but maybe I will just. I won't show you my Android app, but I will just send this value, this text value, to characteristic. As a write command, not write request, and hopefully the light bulb will talk to us. Okay, sent.
Hello, Hack in the Box Cyber Week.
I don't know if you have heard it. Maybe I had like some not very loud speaker, but it just said hello, because this is a talking smart light bulb. I hope you will figure out how to do it. I don't want to spoil you the fun. Let's get back to the slides. All right. Okay. Okay, so for writing, you just send you just use this write, and there is a pop-up that shows you like how to write the value. Again, sorry. Okay. So this is the expected result. I can see that it worked for many of you. I don't see any complaints here. But if you have a problem, just reach me later and we'll try to figure it out. Okay, I hope you will be able to make your smart light bulb to talk to you also. This will be your task. I won't reveal the exact steps, but you can always use the hints. So if you have a problem, you can scroll down to the hints and use the hints. So it should get you easier to solve this task. By this point, we have finished like this basic introduction, let's say, how this Bluetooth Low Energy works. So we've covered this device advertisements and also connections. So you were able to connect to device, read, subscribe, and write something back to it. So we can use these skills to attack a lot of very simple devices, surprisingly lots. Another task is to send some other command to this light bulb, a command that is slightly more sophisticated. It's not just 0001. This is a command that sends a color value to the light bulb to change its color and to dim. So if you have a if you have a device that is connecting to your smartphone, how can you understand this protocol? Like basically, you can just try to sniff it. So you can intercept it in the air. And if it's not encrypted, you may be able to understand the packets and just figure out what is going on here. And by the trial and error, like switching various options, you will be able to reverse it. Another option is to reverse the firmware of the device if that's available, and you know how to reverse the firmware and so on. This is usually way more difficult and tricky than reversing mobile application. And I guess at least some of you had something to do with mobile app reversing. And if not, it's really, really simple in many cases, because you just grab this Android APK binary and you just feed it to some decompiler. And this decompiler, like JEDX, it will show you some internal secrets of this smart lock, for example, application, how it works, including some secrets and including packet format and so on. So this won't be like the exact Java that was written by the developer, but it will be in most cases, unless the developer didn't obfuscate it especially, in most cases it will be readable enough to understand it. This task is actually to understand this fragment of decompiled Android code and to figure out how exactly this protocol works. So you need to send a special command to this light bulb that will change its color. And again, I won't show you this exact command, but I can show you that it's working for me. Yeah. We just skipped the write automation for some reason, but we'll get back to it. Okay, so let's move on. Okay, so this phone is not, I will not show you the exact data I'm sending because I don't want to spoil the fun for you. I will just send the value to the phone that will switch the color to the half dim red. I can switch to another color if I want. I just leave this to you. The task is just to change it to half dim red. All right. So it did work for me. I hope it will work for you as well. There are some nice hints in case you have trouble. So you just press this icon, give me some hints. I can't. It will explain you something about it, and hopefully will allow you to solve this task. All right. So now the moment you've been waiting for. So I have this dildo device, and I'm going to connect this device and try to control it. So it's on my desk here. I will use NRF Connect to, I will first turn it on. I will scan for this device. Right. Yeah, so I'm connecting to it, and I just need to know what value to send to each service and characteristic. So I know that this is this specific characteristic, 555 FFAA, if I'm not mistaken, and it just vibrates. So come back here. So I will need to send it again, C55500, and it stops. So there is also no pairing, no authentication, and whatever. I just need to know what to send to this device. I just connect to it, and I can send some stuff. Right. Okay. So this was the backup video. So, but the demo worked. So I just sent this value here, like this, just like you will do with this smart light bulb. And actually, I didn't need to hack this device because I could just download this application, and every time you start the application, you just need to you just need to check this device, connect to it, and there is also no pairing, no authentication, whatever. I didn't need to reverse it. I could just download the application and connect to someone else's device. Another very interesting and useful feature is automating these writes. So we just skipped one task, and we'll get back to the 12 write automation. And there is a very, very useful feature in NRF Connect that is called macros. So you could just take a macro and record something that will be replayed with a single button. So let me just show this to you in the live. Okay, so the task is to like turn this light bulb on and off twice per second. And I'm sure some of you will be able to click it in the application, but let's just do this via the macro. So I will disconnect from the Vibe, the big red one, and now I can just send a value 01 to turn the light bulb on. Then I will add some delay using this icon with the glass, and I will add like maybe 200 millisecond delay, and then I will write again 00 to switch the light bulb off, and plus again a delay. And now I can stop recording this macro, and it will ask me for a name, blink twice. And I can also choose an icon for it, like LED, for example, save. And now I have this blink macro, and if I press this play, it just blinked. But you can also select this there is this icon of this one. So if you turn it on, it will replay constantly. So if I press play, it will be blinking on and off again. And finally, it will like allow me to solve the task. All right, I don't see any comments that something is not working. I hope you will be able to like follow up with this writes with these macros. I will show you on the slides again how it works. So you just take this button to enable macros. You start recording, then you record something. You can add also optional delay between requests. Then you stop recording and save the macro as a name. And every time you are connected to the device with matching characteristics, you will have this play button available. And you can also optionally like turn this loop. And this is the like expected behavior. So we can use these macros functionality at some more useful attack that will brute force a password to protect that functionality. So our smart light bulb has a hidden, maybe not hidden, but protected functionality that enables like some special function. And this special function, in order to enable it, you need to know the 3-digit password. So your task here will be to reverse engineer, understand how this protocol works, what is the correct valid format of sending a password, then maybe recording a small macro to send whatever password, and then you can actually export this macro. This is just an XML, simple XML file. And this is how this XML file looks like. So at the beginning, you have some assets and ensurement that these characteristics are available. You can just skip that. And the interesting part is the write. So in this write, you have a description that shows in the NRF Connect, characteristic UID, service UID, and the value and the type of write. So it's pretty self-explanatory. So the task is just to write a series of writes with all the combinations. And again, I won't show you the exact solution, but I can show you how this works in practice, at least for me. So I wrote this macro already. Well, let's see. Here. And now my macro is pass brute, so it has like 1,000 lines. And I added this text description. I'm just try 000 and so on. So I see like this how it works in practice. So I will just press display, and you can see the progress. So it's going like about 10 tries per second for me, and it will finally find this random password. It will tell you about it, so you will notice this. So it shouldn't take really long to like try all the possible combinations. Yeah, let's see. We are already halfway. Five. I'll just give it a moment. 6. 7. Yeah.
Congratulations. Valid pin is 702. Enjoy.
Yeah, I will not show you what happens next. This is a surprise, but it will show you when you get the valid pin, and you will see this special mode of this light bulb. So this will be your homework, yeah, let's get back to the slides. All right. In my case, it takes about 100 seconds to try all these 1,000 combinations. So it's like about 10 tries per second. That was my case. Your system may vary. You could send a lot of these using write command, not request, but your system probably will not be able to parse it because it will get like 3 times more packets at the time. And I suppose the standard devices will also not be able to parse it. So this is the output of this task. There will also be some surprise special mode. I hope you like it. Using this the smartphone, you can hack like simple devices, even the devices that have some password enabled. So you could brute force this password. So now let's move on these skills to some real devices like smart locks. I don't see any questions so far, so I hope you are okay. You are still with me. Let's move on to gun safe. I also have here. It looks like this. And it's pretty heavy. It's solid metal. It can be unlocked using Bluetooth application. And in the manual, you see that the users should change. It's not enforced. This default 1, 2, 3, 4, 5. So let's hope that the user did change this default password. But they are limited to between 4 and 8 keypad entries. And this keypad has only like 5 digits. Mine are worn out, so, but, I made a very rough calculations. If we would assume that we are able to try 10 tries per second, just like it worked for my hackme, then if the user chose like 4 digits, we could be able to brute force it in about a minute. If the user chose 6 digits, it would take 4 hours to try all the combinations. But if you would try just maybe the commonly used passwords, a dictionary attack, then of course our chances are very like higher. because most of such devices do not have any brute force preventions or soft locking or notification to the owner that anything goes wrong. You could try multiple at the same time, but not all devices allow for multiple connections. Lots of simple devices allow just for one connection at a time. And also keep in mind that this device is usually powered by very low power CPU. So it might not be able to process all of the parallel requests. Yeah, they probably use 4 digits, and we'll get to this later. And by the way, you actually don't need to boot the code because you can unlock this safe without knowing the code because there is a Bluetooth vulnerability in the protocol. So you can unlock all of these safes without knowing the code. And so when I saw this vulnerability announced, I bought this safe from Amazon. And it turned out that they couldn't patch it because they didn't have any update process. You need to send it back to the vendor in order to patch it. And I was really happy. I ordered it like 3 months later. I was really happy to get a vulnerable one. So 3 months after they announced device callback for patching, they were still selling the vulnerable ones. Well, I'm happy because I wanted vulnerable one for shows. But I'm not sure if the owners are aware of it. Right. Yeah. Happy to get vulnerable one, yes. So let's move on to another real device, and this is a real smart padlock. So this is the next task. In the next task, the hackme device will be working exactly like this padlock, and this is called quick lock. The vulnerability of it was announced by Anthony Rose and Ben Ramsey during DEF CON 24 in 2016. So among lots of other smart locks, they sent the password in clear text and also are vulnerable to replay. They used an external sniffer. They used Ubetooth to sniff this communication and figure out what's going on. Sniffing is actually the first thing you think of about when you think of hacking Bluetooth. But just as a side note, in a very lots of cases, you don't need to have an external sniffer because the sniffer is required if you want to sniff the packets from the air. And it's helpful, or if you are an attacker that stands out of the reach of the actual device. But if you want to analyze an application that works on your own phone, and this is majority of cases for penetration testing, you don't need to sniff the packets from the air. You can get them from the phone because there is a functionality called Android BT Snoop, and it saves the pickup file that is visible in the Wireshark. And some phones like Nexus 5X with Android 8.1 and some other phones like Xiaomi, LG, and a few other models, they have it enabled the real live flow that you can see the packets live. You don't need to download this file later. So about the sniffers, let me just give you some brief. So the most renowned one is Ubetooth, but it's one of the more expensive as compared to the other open sniffers. I use very often the NRF sniffer. It's closed source, but it has very nice integration in Wireshark, and you can actually use it with these small chips that cost about $5. You just need to connected to serial adapter. I use such boards for it. For example, you can have such board and this for $15. And it works surprisingly well. It also works on like these USB dongles from Adafruit. And by the way, you will be able to win this one, so stay with me. Another sniffer and Bluetooth attacker is Beetlejack that also works on this and also works on BBC Microbit. And last but not least, the first Bluetooth sniffer, open sniffer that is capable of sniffing Bluetooth 5 is SniffLE. And it also has a very nice improvements in reliability. Long story short, about the sniffers, there are multiple options, sorry, sorry for this. They all actually dump to Wireshark, which is industry standard. If you don't know Wireshark, just download it and you will figure it out pretty easily. So you have the list of packets, decoded packet, and raw hex. There are some tricks in Wireshark that I use to decode BLE packets. So let me go to this hackme device. So if you go to this smart lock replay task and scroll down to the task description, you will see a link here to a pickup that I created this pickup using this sniffer. And if you download this pickup, you can open it in Wireshark. Let's move on to Wireshark. Yeah. So if you open it in Wireshark, you will see lots of packets that are actually advertisements. So you can have a look inside these advertisements and see advertising data. In the advertising data, you will see that this device advertises padlock name. I can show you how this looks like in NRF Connect. You just see the padlock name. You may have some trouble finding your way around all of these packets. So my favorite trick is to limit them to only just the ATT packets, so the services, so characteristic read, write, and so on. So I use a filter called BTATT, we don't have these advertising packets anymore. This is just an intercept connection. And at the beginning of this connection, the phone checks inside the device what characteristics and services are available. Slightly later, you will see some reads and writes. It's also not really visible what's happening at the first time. So if you catch a value somewhere, you could take this Bluetooth attribute protocol here, write response, value notification. Oh yeah, so we have a value here. If we right click on the value, you don't see my right click, sorry, but right click and you will see apply as a column. You will see a new column value here. So you will be able to easily browse it here. And in this way, you will see the exact communications, the reads, writes. So this is the communication of a mobile phone connecting to the smart lock. So the mobile phone is a slave here and connects to the master, the smart lock, and sends a write to unlock it. So your task will be, oh, I moved again these smart pants. So your task will be just to understand this communication, figure out where exactly is sent the password, and create a macro, or maybe not macro, just special writes by hand to unlock this lock. So I can also show you that this works for me. I will not show you the exact solution. And by the way, now you need to disconnect from this device and scan again, because now it advertises some other, as it's visible as other device. You see other services and characteristics. They actually use the restricted ones as proprietary ones, but this is how this real device looks like. And this real device also has descriptors for each characteristic. So I just cloned this descriptors and everything. So if you have this unlock script ready, so then you can just send and it should unlock. And this will be your task. So let's get back to the slides. Right. All right. So some Wireshark tricks, replay, and this is the response of the vendor. So when it was published at DevCon, so they had to respond somehow, and this response is a little bit bizarre for me. So this is unencrypted by design to allow vendors flexibility, and it's kind of lame response for me. Yeah. So I don't know, you can do a really good encrypted by design, but also open. Yeah. By the way, in the meantime, someone asked about Ubertooth. Is the latest firmware from 2018. It's not really very actively developed, but it's still working. But anyway, if you would like to buy a new Bluetooth sniffer, I would encourage you to buy this Bluetooth 5 Sniffer LE. That will be slightly cheaper, also open source, and it will work for Bluetooth 5. And getting back to this security notice of the quick lock, you can also read at the same page that many users never update the default password. And when they call off the tech support, our first option is to have them try the default Bluetooth password, which is 1234567 and it works. Just like that. Some users do not change this. So, and by the way, it also has an RFID card that can be cloned in 15 seconds or whatever. Yeah. If you don't enforce the security, they will leave it default probably. Anyway, I think we are supposed to finish in about 5 minutes, so it took slightly longer than expected. I still have some slides about smart locks, other smart locks. I can quickly go through them and show you the end notes. Or if you can stay longer, we can be slightly longer here. I don't know how many of you need to go to some other session and so on. So if it's not a problem for you, we'll make it slightly longer. I think I should finish in 15 minutes, I suppose. Okay, so more is fine. Okay, great. So if anyone needs to leave now, sorry, you will be able to replay this session later, but I see ACKs for more stuff. So we'll continue with the smart locks that can be hacked using just a smartphone. And another one is called a smart lock. I have it somewhere here. Yeah, looks like this. And it's just called a smart lock. You can see smart lock. Yeah, if you don't believe. Long story short, this one has a mobile application that can be easily clicked, and in the first smart lock class, you will see something like that. Can you see this? Yeah. Okay. So here's the super password encoded in the mobile application. So when I first saw it, I was maybe let's try this 741 and so on and the lock. And no, it didn't work, unfortunately. So I needed to dig slightly deeper. So in the application, I found some other types of requests. Among other things, there was a request to reset password, and the command for it was 08. So I created a simple script that takes this initial handshake that you can just replay because it's just based on the MAC address, whatever. The actual communication happens here. So this is this super password. You can figure out the command by STX161 is AA. So you can figure out the command. I send this super password in a command 08, which means reset password, and then I can just unlock it with the default password. And so I wrote a very simple macro for NRF to do this. And it actually takes a few seconds to do it. You just press play. It unlocks, and the password is changed. And it's, by the way, very deadly hack because the original owner of this, his application doesn't know that the password was reset. So he gets an error and he actually gets cancer. So I called it a very deadly hack. If you're interested in more, I wrote a blog post about it, so you can click some details. And you may have heard of another very famous smart lock called Taplock, which actually uses MD5 of the public MAC address as a password. So this MAC address you saw in NRF Connect, it's public. So you can just see it calculate MD5 of this MAC address and authenticate to the lock, and it takes 2 seconds. And it wasn't really difficult to figure out in the source code because it could be easily decompiled. You can follow this Andrew Tierney's blog post about it, who discovered it. So, of course, I wanted to have this one also. So I bought one on eBay, and it turned out that it was another security researcher selling it because he just bought too many of them. He just wanted to get rid of them. And actually, a security researcher which was going to the same conference in a few weeks in Paris, at which we were both speakers. So we met here and we tried this trick with his lock. And so this is the combination that worked for Andrew. So we tried with this MD5 of MAC address. So we were it doesn't work. Why it doesn't work? And finally, I saw the actual packets. So it turned out that Lucas lock had a special, maybe first version of the firmware, which had the hard-coded 1234 as a password, not MD5 of MAC address, not that much complicated. So it was just like 1, 2, 3, 4. So of course I made a very simple NRF script that just sent this two like packets to the log, and again it takes like 2 seconds to unlock it. And by the way, I then met Stefan Kelling at another conference, and his smart lock also did work for this 1, 2, 3, 4 password. So there are apparently more smart locks, more tap locks that work with this 1, 2, 3, 4, not very complicated MD5 of Mac. Right, so these were the smart locks, and now I have a competition for you. So you can win this NRF sniffer based on Adafruit USB dongle. And we have 3 of them for the people who will solve all the tasks. And you just need to send the macro scripts that were used to unlock the smart lock and macro script to brute force the passwords. And I know it might be challenging to make a screen up of all the solved tasks because the app may crash in the meantime. So if you have this problem, just write down your like very detailed description of how you did solve the tasks, and along with like the valid responses, and we will take a look into it. So the first people who will get this, who will solve all the tasks, will get this sniffer, and also. If you are interested in something more, I really encourage you to take these skills against real devices and let me know how it works. So there are also some other tools that will be helpful to run on Linux. And if you'd like to do a relay or man in the middle, I especially recommend this new Mirage tool. You just need 2 dongles and you do man in the middle. One device simulates, another like connects to original one, and you can do this on remotely. You could use also Beetlejuice or my own GATT that I based on Node.js. The Mirage is based on Python and works like way better. And if you're interested in Bluetooth link layer encryption connections that are not that common, you can try these tools, links. And we didn't talk yet about Bluetooth-related vulnerabilities, which are like, if you have a look at them, like it looks like the namespace for the vulnerability name and logo is filled, but it keeps getting better. So some of these vulnerabilities are vulnerabilities in the protocol itself, found by the guys who are brave enough to actually read the specification and find some bugs in the specification itself. So it's very interesting reads. And some of these vulnerabilities are vulnerabilities in implementations in specific devices, so some RCs and so on. So Bluetooth is complex, so expect bugs and even more bugs. And if you want to play CTFs, there is a nice CTF by Ryan Holman. You just need hardware for it. But it's very easily available, ESP32, so cheap and easy. I wrote a few years ago another hackme log. It's based on Linux simulated device and Android application. I don't know if it still works. I haven't used it in years, but you can try that. Of course, like subscribe and look up my updates. I plan to push some stuff about hacking smart locks. And we are planning some trainings on BLE and NFC RFID probably February, but we will announce them this year. So if you still have some training budget for this year, hopefully you will be able to like subscribe for it. And yeah, thank you. So, is there are there any questions you would like me to ask here, or shall we move to this like Discord channel? Like I see some. I have the vulnerable Taplock. Yeah, from Stefan Gerling, the same Stefan that I showed, that I met in Hack, and I showed his log in the video 3 slides back. Nice to meet you, Stefan, again. Okay, so I see some questions, so I expect you want me to answer them here, so I can answer them here. So is it actually hard to read 3,000 pages? Well, it's more than 3,000 pages. And if you want to read it with understanding, yes, it is hard. And not really a lot of people read it. So I encourage you to try out, and maybe you will find out another bug. Yes, so can you break a device by sending wrong info and data? That is possible. Potentially, I did break one device because I sent something that was stored in the device flash incorrectly. And also, these devices are very vulnerable to fuzzing. So if you send something invalid, you may end up in a not working device. Like lots of smart locks, when I send invalid packet, they just stop working. So I need to reset them. And this might be a problem for an owner, for example, because you need, in order to reset them, you need to get inside. But you can't get inside because you can't unlock it, because the device is frozen and there is no backup option for a standard key. So, yeah, there is a slight possibility that you can break it like for forever, but more likely possibility that after the restart it will work again. What's the main difference between Bluetooth 4 and Bluetooth 5 MAC layer? Well, Bluetooth 5 has a new physical modulation that allows to send faster transmission. So that is why all the older tools like Ubetooth, they cannot decode this transmission because the hardware doesn't allow to demodulate this. But yeah, it's not really used in practice yet. So not really a lot of devices use this new modulation. You would need to have a Bluetooth 5 compatible phone and Bluetooth 5 compatible device. And it's not really a lot of devices at this moment. This will change in future probably. Bluetooth 5 also brings new advertising extensions, that you have longer advertisements, and brings new encoded low-level physical layer that you can transmit at a lower speed to higher distance, and this also cannot be decoded by at least some of the old hardware. It can be partially decoded, but not all of it. Yeah, let me scroll to the questions. Brick device, Bluetooth 4. And Bluetooth 5, I hope I answered it. Can you repeat which Bluetooth sniffer you recommended? Yeah, well, I personally use most often the NRF sniffer on NRF hardware. Like this hardware can be, this can be NRF board, or this can be this board, or this can be like this $5 chip. Or this can be this USB dongle from Adafruit. I use it most often because it has a nice Wireshark integration, and I just skipped this slide for some reason. Let me just show you the slide if you don't mind. It was just a few slides back where actually it did work very nice, but if you are, it's cheap and it kind of works pretty nice. Okay, let me just show you this specific. But if you are into buying a new sniffer, then probably best would be to buy this. Okay. Probably that would be to buy this, because this works for Sniffle. This is Texas Instruments development board that costs about like $40, and it will work for Bluetooth 5. And this is how this NRF sniffer works. So you have this nice toolbar in Wireshark, so you can select this specific device you want to sniff, and it will just follow this specific device. And it's just nicely integrated and easy to use. So I like to use it because it's like easy to use and works good enough. But this Sniff LE is way more advanced in the features, and also captures the packets in a more reliable way. Long story short, Sultan figured out how the sequence of packets will be transmitted. I didn't want to like get into too much details. So another question was, I reported a couple of smartbots, so we can break them, causing buffer overflow. Yes, unfortunately, buffer overflow with these devices is pretty common because it's just the simple C, and there are no like any protections whatsoever. And I saw lots of buffer overflows as well. Sniffer link, yes, okay, great. Thank you for session. Doesn't Sniffer has external antenna to connect to? You could figure it out. There is an option to like, there is an antenna here, but I think by default, you can see the antenna here. But I think, as far as I remember, by default it is unpopulated, but I might be wrong. I haven't used it in practice, actually. It works good enough in the close distance. So as far as I remember, you will need to like break some of these connections here to make this antenna work, but I don't really remember this. I can follow up with it later. I think Sultan, when he presented this tool at Hardware I/O, so look up for his presentation. So I think he actually talked about it as well. I don't really remember. Yeah. Okay. So here are the here are the sniffers. But in many cases, I actually use sniffers not very often because I just use it when I cannot dump the data on the phone, when I analyze an application or something doesn't work, like so for proof of concept. So you need sniffer if you are like a bad guy outside and you want to sniff someone else's lock or whatever. Thank you. Yeah, I know, of course, I know this presentation from CCC, of course. Yeah, very nice. I couldn't like link all of them. Can we use crazy radio? Well, you could use SDR to sniff. I didn't include SDR here on purpose. You need to have 2.4 gigahertz. So you would need HackRF, for example. And second, it's not really reliable. So it works way better when you leave the low-level packet handling to the hardware and you get just the demodulated data. So you can sniff Bluetooth using SDR, but you will get some errors and it will work slower. Yeah, you can try it just for the sake of trying, but I think it's a better option to use hardware-supported sniffer. Okay, Bluetooth has frequency hops, which SDA cannot help. Yes, it can help. So I didn't want to talk a lot about this frequency hopping because I didn't want to introduce you the low-level technical stuff. This frequency hopping can be discovered. So this frequency hopping is established between two devices when they initiate the connection. So if you are able to capture the packet during this connection initiation, then you know the hopping sequence and you can hop along with the devices. And also, if you want to intercept the ongoing connection, Damian Kakil figured out how to do it in his Beetle jack. So it is also possible without even knowing this first initial packet to figure out what is the hopping sequence. And it should be possible to apply this Damian's technique to SDR. Yeah, I hope to see you in person as well. Any more questions? Yeah, of course, I hope you will be able to help me debug this new hackme software. Like I mentioned, it's the CTF links. The CTF links. All right. So let me just go to the next slide. If you look for BLE CTF, you will definitely find it. There is actually a new version, CTF Infinity, which is infinitely developed. And my old hackme, I still don't know if it works, but maybe it would be useful. It was supposed to show the vulnerabilities that could be exploited by using man in the middle for Bluetooth. Okay. So these links are also on the slides, and you should get the slides link at the beginning of the session. In the scroll up to the chat. And I will also send you the follow-up with the slides as well. So, yeah. How is actual data like streaming music transmitted, and can it be sniffed? Streaming music is usually transmitted using the older Bluetooth BR EDR, so basic rate enhanced data rate. So there are devices that support both types of connections, Bluetooth Low Energy and older Bluetooth. And streaming is usually done by this older because it's faster, and you need pairing for that. This can be sniffed if you can intercept the pairing. More or less, let's say. I'm not an expert in this BR EDR. I actually never did sniffing of BR EDR. I was focused only on Bluetooth Low Energy, which is basically a different protocol. All right. So, any more questions? I can, of course, stay longer. Again, I hope you will be able to help me with debugging this new hackme. So if it crashes for you, please let me know when exactly it crashes and how to reproduce this bug. I know this can be crashing during switching the devices simulated. I didn't caught all the exceptions and so on. It crashes when you do a read. Yeah, just get back to me with the details in private, an email or issue on the GitHub. So hopefully we'll be able to figure it out. If you are able to install this Visual Studio and run the source code, you will have a very detailed debug information that will be helpful to figure out where exactly in which line of code this problem exists. So if you are able to like run this session through Visual Studio, it will help me a lot to debug it. Great. So what else? I don't see many lot of questions here now. So maybe if you do have more issues with this hackme, or if you do have more questions, let's meet later at the Hack in the Box dedicated Discord channel, and I will be here in like a few minutes, let's say, just to get some refresh, and hopefully, if you have any questions later, I will be able to answer them as well. If you don't have any questions at this moment, I will leave you to your other plans for today. So thank you very much for attending it, and hope to meet you someday in person. And let me know how your Bluetooth hacking goes.